Okay, hi everyone, welcome back to Code of Hope. In today's tutorial, we are going to be covering lists. So, ideally, a list in Python is a built-in data type, and these are used for storing multiple items within a single variable. So, an example could be a list of fruits, where we have a variable called fruits, and this is initialized to hold values like mangoes, apples, and maybe berries. So it's important to note that these lists have particular features, and one of them is lists are ordered. In other words, items have predefined positions. So here items have predefined positions. Our second key feature about lists is that they are changeable. So with this, it usually means that you can add. So in here you can add, update, remove, etc. So you can perform all these operations on your list. And equally, they allow duplicates. So you could be asking yourselves, how do lists allow duplicates? Remember, they are predefined positions. So whatever you add to the list has a given position within the list. So you could have multiple things having the same information, given the fact that they're holding different, they are within different positions. And lastly, the lists can store mixed data types. So these store mixed data types. Now that we have the understanding of what a list is, we're going to look at how to access items in our list. Take for instance, I've mentioned that each of these items has a predefined position. It's important to note that within lists, each item has an index. Take for instance, the mangoes has an index, the apples has an index, and indexing within the list starts at 0. In other words, our mangoes is at position 0, and this is at index / position 1, and so on. So if at all I wanted to access the mangoes, then I could simply have a print statement here and simply say print my fruits at the position of 0. And if we try executing this, you would find that it would give us our mangoes. So mangoes is at position 0. So indexing, we have both positive and negative indexing. So currently we have been using the positive indexing where we have 0, 1, and 2. However, lists equally support negative indexing. So when using negative indexing, -1 gives us the last item within our list. So for example, if I copied this and printed it out, and this time round I pass a -1 here, we simply expect to get berries being returned for us, since it's the item at the last position. As you can see, we have berries being returned for us from the fruits of -1. So we can equally access more than one item, whereby we can apply things like slices within the list. Let me add here some other fruits, and I'll say passions. So we now have 4 fruits within our variable fruits. So how do you access multiple items? I might want to access mangoes, apples. So by doing that, we have something we call slicing within lists. So to access a slice of the list, we need to have access to the starting index and the ending index. So we need a start and the end. So I could simply say print out my fruits, and I'll open up the square bracket. Then I'll specify the starting index. So I might want to start from mangoes or from apples. So apples is at position, sorry, index 1. So I'll pass here 1, then I'll put a colon and I'll specify the end index. I could say this is 1, so this is 0, 1, 2, 3. So I could say 1 to 3. So when I specify that I want to pick items from 1 to 3, 1 is inclusive. So the item at position 1 will be included. Then we shall have item 2, but this last index is not added. So this last index value will not appear. In other words, we shall simply have the apples and the berries being returned for us. So let us run this and see within our CMD. So right there, exactly just like I've explained, we simply have the apples and the berries being returned for us. So we have multiple other ways of performing our slices. I could say I want to get items from index 1 all the way to the end. So this will give us all items starting from apples up to the end of our list. Equally, we could have other variations of the same, where I could maybe say I want from the start all the way to index 2. So this will equally give us the same thing. So mangoes and apples. One thing you should know, the last value here is not included in the response that we shall get back from the particular statement that we're executing with our slices. So right there we have been able to slice, and again we have other variations, just like printing out fruits and specify just that single colon. So this returns back for us the entire list, as you can see. And equally, you can have the same and have from the start to the end, and this will equally give us the same, the entire list that we have. However, we could do from the start to the end, and basically reverse this. We pass here -1. So this is going to give us a reversed list, just like, as you can see, we have passions, berries, apples, and mangoes. The last thing I can talk about slices is we can equally slice together with a step function. So I could say one from the start to the end, however, in steps of 2. So when I do this, it means when I print the mangoes, I'm going to skip apples, then I'll print berries, then I'll skip the passions. So our response is simply going to have mangoes and berries for this particular statement, line 21. So as you can see right there, we have the mangoes and the berries. So let us look at how we can change some items. So changing items within our list. Now you might have the interest of changing maybe mangoes, changing apples within the list. So this is equally straightforward. You simply call your list name. So this is going to be my fruits. Then you specify the index of the item that you want to change. So in this scenario, I want to change the mangoes. So mangoes at index 0, and I'll assign this to a new item. So let me see, we have mangoes. Maybe I could say this is going to be maybe jackfruit. Jackfruit. So if I now print out my list after that particular change, you'll find that the item at position 0 is a jackfruit. So this is how you can change. And equally, you can change more than one item by equally specifying a slice, and it will change all those items that you have specified within that particular slice. So how do we do that? So I could say I want to change my fruits from position 1 to position 3, and this is going to be equal to, now you specify the items that you want to put there. So I could maybe simply alter them, and I will say this is now going to be position 1 will be mangoes. I'll put a comma. Then position 2 could be maybe the apples. So this is going to change ideally only to item. So non adding the third item. So let us print this out. Sorry, print this out. So print out our fruits. So let's run this file. So right there, you can see that we have inserted mangoes and apples, and eventually we have our passions at the end. So this is how you can change items within our list. So it's important to note that we have other methods. Now the methods enable us to manipulate our lists even furthermore than just what we're doing currently here. So let us see how to add an item, but ideally the addition, this can be done within our list methods. So I think I'll jump straight to list methods. We shall see how to work with the methods. So right here we have our list methods. Our first one is going to be the addition. How do you add an item to the list? So this is going to be employing a method called append. So we call our list and call the append method to it. So inside append, you specify the item you want to add. So let us add here maybe pumpkins, a pumpkin. So given the fact we have added this, we need to verify that this has been ideally added to the list. So what append does, it adds this item to the end of the list. So just after passions, we shall find pumpkin added there. So let us run the file and see. So perfect. We have the pumpkin added. So we equally have the insert method. You might want to insert something or to add something, not really at the end, but rather I want it in between apples and passions. So in there we do that with the help of the insert method. So you simply call your fruits and dot this with the insert method. So inside insert, you specify the index. Where do you want to add the item, the new item that you're specifying? So this is going to be added between maybe apples and passions. So you should be knowing the index of apples. So this is 0, 1, and 2. So this is at position 2. So I could simply say I want this to be added at 2. Then you now specify the new item. So what other fruits do we have? I could say guavas. So let us print out our fruits and see. So right there, so our guavas has been added and it's at index 2. So as you can see 0, 1, and 2, then the rest comes in there. So that is the insert method. So just after inserting, you might have interest of removing. Maybe I want to remove something. So just like the method is, you simply call the remove method. So this is going to be fruits dot remove. Then you specify what you want to remove. So I want to remove the pumpkin. This should be a list, sorry, a string. So pumpkin. Then you could print out your list. So let's run this and see. So right there, the pumpkin has been removed. So you can equally remove something using the index. If I told you know the index and you don't simply want to use the name. So I could say fruits dot pop. So what do you want to pop? I want to pop whatever is at index 1. In other words, you shall be removing the mangoes. So I'll again call my print of the fruits. So I'm able to verify what I have removed from the list. So right there, we have removed mangoes, and now we simply have jackfruit, guavas, apples, and the passions. So that is for the removing. Next, you might want to find the index of something. So we could simply print out maybe my fruits dot, I want to know the index of guavas. So currently guavas is at index 1. So if I run this, you'll find that it's going to give us a 1. And it's really the position of guavas within our list. So we have the count method. You want to know how many times a given item is appearing within the list. So you see, you can simply call the count method, and this will be my fruits dot count, and you specify the item you want to count. So I could want to count apples. So I expect this to return for me equally 1 because we only have apples appearing once within this particular list. If at all apples was appearing 3 times, then this would give us a 3, given the fact that it's appearing thrice. So we have the extend method. So I could have another list of items. Let me just choose a random list of maybe other fruits. Let me call this other fruits. And this is going to be another list where I could say maybe berries as well. I come and say bananas. So I might want to join this list to the initial list that we had, the fruits. So how we do that is with the extend method. So I could say my fruits dot extend, and I specify the new list I want to extend my fruits with. So this is going to be the other fruits. So when you print out our list now for the fruits, we shall find that it has been extended with the new list, and it's now much longer than the initial list that we had. So that is the extend method. The other method is copying. You could want to make a copy of the actual list you have at hand. So I could say my list copied is equivalent to, so this is going to be my fruits dot copy. So this is going to create for me a new list, and it's going to be stored into variable list copied, and it's going to be ideally identical to the current fruits that I have. So you could verify that by printing it out, list copied, and it should look exactly like this initial one right there highlighted. And as you can see, they are really the same exact items that we have. So next we have reversing a list. As you can see in here, this reversed our list, but equally we have a reverse method. So I could simply say my fruits dot reverse, then I print out my fruits, and this is going to be a reversed list of the actual fruits that we had. So bananas comes first, berries all the way to jackfruit, as opposed to the initial that had jackfruit starting first all the way to the end. Then we have the sort method. The sort method is used to sort our fruits, our list of items. So I could simply call fruits.sort, and I print out my fruits. This is going to sort our fruits in ascending order, as you can see. However, if you want this in descending order, so this is hashtag ascending order. If you want the same thing in descending order, then you simply call your fruits.sort, then you specify that reverse is true. So this is going to return your fruits in descending order. Sorted, however, in descending order. So right there. So it's the reverse of simply sorting. So it's important to note that this sort method modifies the actual list that you have at hand. In scenarios where you don't want to perform the modification of the entire list, then you can use the sorted method. So I could say my sorted list is equals to, we call the sorted, then we specify the iterable, so this is going to be fruits, then you specify the criteria of sorting. So I want my reverse to be false. So this is, let me say reverse is true. So this will perform the same sorting like this. However, this doesn't modify the list that we have at hand, as opposed to the first one. So I could print out my sorted list, and they're going to be the same exact things, just like the sorting did with reverse true. Difference is modifies the list, and this doesn't modify, it simply returns a new list for us. So we have other methods that we can use, maybe for sorting or for whatever you might want. So I could call the same method. However, this time round, I want to sort this on a different scenario. I could want to sort this with the length of the items, so that whatever has a shorter name appears first, and whatever has a longer name appears last. So you'd have your sorting in that format, and this is being sorted with the length of the items that we have. So right there, we have looked at the lists, and as of now, I believe we are really capable of working with them, and equally their methods, together with the different levels of accessing items and slicing them. So we have other approaches, and these are called list comprehensions. So what comprehensions help us with? They help us to modify the actual list that we have and return for us a new list following the criteria that would have been specified in the comprehension. So let us start by looking at maybe a loop. We go through our list of items that we have, and for each of those items, we could do something with them. And after that, we also look at the same approach using a comprehension. So first it's going to be a for loop. So we can say for item in our fruits. So what are we going to do? Maybe we want to get items whose length of the length of the characters we have in there is less than 5 items, less than or equal to 5, and anything more than that, we discard it. So we could say selected items up here is equals to an empty list. So if at all the length of this item is less than 5, yeah, so we could have a condition here and say if the length of the item is less or equal to 5, then what do? We add this item to the selected items. So selected items dot append the item, and eventually we can print out the selected items. So let us see the list of these items. So it's giving us an empty set. So let us see 1, 2, 3, 4, 5. So most of them are 6. Let us make this to 6. So we have at least some items being returned for us. So right there, we now have 2 items. As you can see, we have written a couple of lines of code to do this. So with a comprehension, I could again simply say my new selected is equivalent to now a list. Then inside here we put our condition. So I could say we shall get this item. So for item in fruits, now we put our condition. If the length of the item is less or equal to 6. Now, as you can see, this item is going to be added to our list of new selected if at all this condition is valid. So I could simply now print out my new selected, and it's going to be the exact list like the upper one. as you can see. So fewer lines of code achieving the exact thing, just like in here. So this is a list comprehension. And with that, this comes to the end of our session, our tutorial on Python lists. I urge us to keep practicing, and see you next in our coming video.